All right, so we have some enrichment problems that we're going to go over on balancing redox in both acidic and basic conditions. So if you're watching this as an online student, you can download this file from the course website, or you can simply pause this video, try these questions for yourself, and then hit resume when you're ready to see the answers. So here are the 4 problems that we did on balancing in acidic solution. And here are the 4 problems that we did balancing in basic solution. So now we're going to spend time going over each one of these so that we all understand how to do it. So because these are net ionic equations, obviously the first thing we need to do is write it out, right? Because we have to write our redox reaction, assign oxidation numbers, and then do the half-reaction method. All right, scroll up just a little bit. Excuse me. Okay, so these are all aqueous solutions. So we've got HNO2, right? That's nitrous acid. And dichromate. And that's producing nitrate ion and chromium 3 ion. All right, so the first thing we do is we got to go through and assign all our oxidation numbers, which again, if you need review on that, please spend the time reviewing that from Chem 1, okay, because that's a crucial prerequisite skill for being able to do this. If you can't assign oxidation numbers, then you can't decide who's oxidized and who's reduced, and you can't do anything beyond here, right? You've got to be able to assign your oxidation numbers. All right, let's do our oxidation half-reaction first. You could have done the reduction half-reaction first if you wanted. I just arbitrarily chose to do the oxidation first. All right, so what's getting oxidized? So nitrogen's going from +3 to +5, right? So that's oxidation. So let's start with HNO2. Give myself some room here. HNO2, and it's going to NO3 minus, right? So it's going from +3 to +5. So that's a loss of 2 electrons. Because remember, oxidation involves writing electrons as products. Now we need to balance for the remaining aspects, right? There's 1 nitrogen, so we're good there. We don't need any coefficients. But there are 2 oxygens on this side, 3 oxygens on this side. So that means we need another oxygen over here. So let's put an H2O, right? But now we've introduced a new problem. What's the problem? We've got 1, 2, 3 hydrogens on this side and no hydrogens on this side. Since this is occurring in acidic solution, oops, I forgot my coefficient. Since this is occurring in acidic solution, we can grab as many hydrogen and H pluses as we want. It's 3 H plus because you've got 2 in the water and then 1 in the HNO2, right? So don't forget to factor in this one as well. That's why it's 3 H plus. And let's see, now we're balanced, right? Got a balanced half reaction, yes. All right, let's do the reduction half reaction. So we're dealing with the dichromate now. So Cr2O7 minus, right? Because it's going from +6 to +3, so that's a gain of 3 electrons. Now, if each chromium gains, let's just draw our arrow here. It's going to Cr3 plus. If 1 chromium gains 3 electrons, well, look at this. There are 2 chromiums here. So I need a coefficient of 2 here. And if 1 chromium gains 3, then 2 chromiums are going to gain 6 electrons, right? So you got a balance for number of atoms. There are 2 chromiums. Each chromium gains 3 electrons. So 3 electrons for the first chromium, 3 electrons for the second chromium. So that's why we have the coefficient of 2, and that's why this is 6. And now we need a balance for oxygens and hydrogens. We've got 7 oxygens here, got no oxygens here, so that means we need 7 H2O, right? But now we need to balance the hydrogen. 7 times 2 is 14, right? So I've got 14 H plus over here. And now I've got a balanced redox reaction. So let's just clean this up. So we've got less going on the board here. Because really all we're interested in are the half reactions at this point. Okay, so now we're going to combine, right? We're going to combine. So we've got 6 here, we've got 2 here. So we're going to multiply this whole thing by 3, and then we're going to add them up, right? So when we combine them, multiply and add. We don't need to do anything to the bottom one. I'm just gonna rewrite this one for simplicity's sake, right? When I multiply this whole thing by 3, that gives me 3 H2O plus 3 HNO2 produces 3 NO3 minus plus 6 E minus plus 9 H plus, right? And then we're just going to rewrite this one underneath so we can cross out all the stuff we need to cross out. So let's just rewrite it. 14H plus plus Cr2O72 minus plus 6E minus produces 2 Cr3 plus plus 7H2O. Now let's add those up. All right, and we can do some simplification. 3 waters here, 7 waters here, so I just subtract those out. Right, so that becomes 4. We've got 9H plus here and 14H plus here, so that becomes 5. Obviously, our electrons cancel. And now that leaves us with our final answer, which would be 5H plus plus Cr2O72 minus plus 3 HNO2 produces 2 Cr3 plus plus 4 H2O plus 3 NO3 minus. And that's my final answer. Now again, if you're doing this for your online homework, it shouldn't be obsessive about the order. As long as your coefficients are correct and you've got the right thing on the right side of the equation, it should be happy. All right, so that's number 1. Let's move on to number 2. All right, so again, I've given it to you in word form. You need to convert that into formulas, balance the redox equation. These are all in acid solution. So first thing we need to do is we need to write, write the equation out so we can see what we're working with. All right, lead 4 oxide would be PbO2, and this is iodine gas producing lead 2 ion, and iodate, which I told you the formula, IO3 minus. All right, so the first thing we have to do is we have to go through and assign all our oxidation numbers. All right, so this is +4, -2, this would be 0, this is +2, and this is +5, and this is -2. So now we need to figure out who's oxidized and who's reduced. So I'm just going to do oxidation first. You could do reduction first. It doesn't make a difference who goes first. So for the oxidation half-reaction, let's figure out what's going on. 0 to +5, right? That's a loss of 5 electrons. So if I go I2 to IO3 minus, right? That's a 0 to plus 5, right? So that is a loss of 5 electrons. But I've got a problem here because this isn't balanced, right? I've got 2 iodines here, 1 iodine here. So I need to change things. I need a coefficient of 2. If 1 iodine loses 5 electrons, then 2 iodines are going to lose 10 electrons, right? So now I've got that part taken care of. Now let's deal with the oxygen situation. I've got 3 oxygens here, right? But I've got a coefficient of 2. So really, I don't have 3 oxygens, I've got 6 oxygens, right? So it's 6 H2O. Make sure you understand why it's 6 H2O and not 3, right? Yes, there are 3 and IO3 minus, but there's coefficient of 2. So 3 times 2 is 6, okay? And now, balancing hydrogen, we have the same issue. Yes, there are 2 hydrogens in H2O, but there's coefficient of 6. So 6 times 2 gives me 12. So now, I've got a balanced half reaction. Let's do the reduction side. All right, so what's happening here? I'm going from +4 to +2. So that's a gain of 2 electrons, right? So PbO2 plus 2E minus gives me Pb2 plus, right? Because this was +4, this is +2, therefore I gain 2 electrons. Now the leads are 1 to 1, so I don't need to deal with any coefficients. I just need to deal with the oxygen situation, right? I've got 2 oxygens here, so I need 2 H2O. But now I've got to deal with the hydrogen situation. 2 times 2 is 4. So now I need 4H plus over here. And now I've got a balanced half reaction. So now I look at my electrons and I say to myself, okay, I've got 10 here and 2 here. So I'm going to multiply the reduction by 5. Right. So then when I combine them, here's what I get. I'm just going to rewrite both. Move that up a little bit so I've got more room. Let's go ahead and multiply this one through by 5. So 5 times 4 gives me 20 H plus 5 PbO2 plus 10 E minus gives me 5 Pb2 plus 10 H2O. And now I'm just going to rewrite this one just so I can cross things out easily. And so I'm just rewriting it. 6 H2O plus I2, 2 IO3 minus 10 E minus plus 12 H plus. Now let's add those up. What do we get? All right, with our H2Os, we've got some reduction to do. We've got 6 here, 10 here, so that's 4. Obviously, our electrons are going to cancel. We've got 12H plus here and 20H plus here, so that becomes 8. So now we can write our final answer. 8H plus 5 PbO2 plus I2 produces 2 IO3 minus plus 5 PB2, oops, got my charge, plus 4 H2O. And that is my final answer. For number 2. And again, these first 4 are all occurring in acid solution. Leave that up for another second while I erase the top. Okay. Now let's look at number 3. All right, so I've given you a word equation. We need to turn it into formulas. So we've got permanganate ion to deal with, right? That's MnO4 minus. And chloride ion, so that's Cl minus. And we're making manganese 2 and chlorine gas. All right, so let's go through and assign all our oxidation numbers. +7, -2, -1, plus 2, and 0. All right, that's it. Let's do our oxidation. So we are going from -1 to 0, right? So that's a loss of an electron. So if we go Cl minus becoming Cl2 plus E minus, right? But we're not balanced here, right? Because there are 2 chlorines on this side, so I have 1 chlorine on this side. So I need to put a 2 here. If 1 chlorine loses 1 electron, then 2 chlorines are going to lose 2 electrons. So don't forget to make those little translations, right? Because if we change the number of electrons here, that's going to ultimately be changing what we multiply by when we are combining the 2. No hydrogens to deal with, no oxygens to deal with, so that was a pretty easy half reaction, right? Now let's do the reduction half reaction. And it's going to be a little more involved because I do have oxygen to look at, right? So manganese goes from +7 to +2, so that's a gain of 5 electrons. So MnO4 minus plus 5E minus Mn2 plus. 1 manganese, so I don't need to worry about changing that number of electrons. I just need to balance the oxygens and hydrogens, right? 4 oxygens, so I need 4 H2O. But then I need to balance the hydrogens. There are 2 hydrogens times 4 gives me 8. Right, so I need 8 H plus. So now I've got a balanced redox reaction. Now I just need to multiply, figure out what I'm multiplying by, and add them up. 5 is not a multiple of 2, right? But I can turn them both to 10. So if I multiply the bottom one times 2, and I multiply the top one times 5, now I can cancel out my electrons. So when I combine, let's multiply the top one by 5. 10 Cl minus produces 5 Cl2 plus 10 E minus. And then let's multiply the bottom one by 2. 16 H plus 2 permanganate plus 10 electrons produces 2 manganese 2 and 8 H2O. Now I just do some cleaning up. There isn't really any cleaning up to do this time because no, I don't have any H2Os to cancel. I don't have any H pluses to cancel. So in terms of cleanup, it's pretty quick. So I'm left with the combination of the 2. And that's my final answer. All right, so that one wasn't too bad. Let's look at number 4. All right, so this is our last one. We're going to do an acid solution, and then we're going to move on to problems that are being balanced in base solution. So we need to write a reaction. Iodide is I minus, and nitrite, NO2 minus, producing I2 and NO. All right, so our oxidation numbers -1, +3, -2, 0, +2, and -2. So let's figure out what gets oxidized and what gets reduced and write our half reactions in, by the way. All right, so for oxidation, let's look at what happens. -1 to 0, all right, so that's a loss of 1 electron. So if we say I minus becoming I2, that's what it would look like. However, we're not balanced in terms of number of atoms. If one iodine loses 1 electron, then 2 iodines are going to lose 2 electrons, right? And then there are no oxygens, there are no hydrogens to deal with, so that's an easy half reaction. For the reduction, let's look at what goes on there. Nitrogen goes from +3 to +2, so that's a gain of 1 electron. Okay, so we've got NO2 minus, oops, NO2 minus plus our electron gives me NO, right? But now we have to balance our oxygens and hydrogens. There are 2 oxygens on this side, there's only 1 over here, so that means I need to balance it with water, right? But now I need to balance the hydrogens, 2 H's, so I need 2H plus over here. And now I've got a balanced redox, and excuse me, now I've got a balanced reduction half reaction. So I'm ready to add them together. Multiplying this one by 2, right, because this is 1 electron, this is 2. So let's combine them. Just going to rewrite this for simplicity's sake. And then I'm going to multiply this one by 2. So that gives me 4H plus 2 NO2 minus plus 2 electrons, 2O plus 2 H2O. Now I'm ready to combine. Electrons cancel. Nothing else to worry about canceling. So now I'm just left with what I have when I combine them together. 2I minus plus 4H plus 2 NO2 minus produces I2 plus 2 NO plus 2 H2O. And there's my final balanced equation. And again, on the homework, it shouldn't worry about order unless it specifically states to put them in a certain order. That shouldn't make a difference. So long as you've got the correct coefficients, they're on the correct sides of the equation. And I'm being lazy here with my subscripts, right? I'm being lazy with writing out my AQs and all that stuff. Because I assume that you know to write subscripts. All right, let's look at some ones that are being balanced in base solution. So when we do a balancing in base, we're treating it like it's acid, and then we're going to make a modification at the end to turn it into a base. Okay, so let's look at some base. All right, so we're dealing with dichromate and mercury. So Cr2O72 minus and Hg, producing Hg2 plus and Cr3 plus. All right, so again, we're going to treat it like it's acid, and then at the end, we're going to make some changes to convert it into base. So, +6 minus 2, 0, plus 2, plus 3. All right, so for our oxidation half reaction, we're going from 0 to plus 2, so that's easy. It's just Hg going to Hg to plus 2E minus. Nothing fancy there, right? No oxygens to deal with, no hydrogens to deal with, so life's pretty good. Let's do the reduction. For the reduction, we've got to deal with chromium going from plus 6 to plus 3. So Cr2O7 to minus plus 6 to plus 3 is a gain of 3 electrons. However, there are 2 chromiums. So if 1 chromium gains 3, then 2 chromiums are going to gain 6, right? Now I need to balance our waters and hydrogens, right? 7H2O, 7 times 2 is 14, so that gives me 14H plus. Okay, that's what it would look like if we were in acid solution. But now we need to tell ourselves, well, this really isn't happening in acid, it's happening in base. So I need to convert this into base. So turn into a base solution. That means that I look at the number of H pluses and I add that same amount of H plus equivalent, which would be hydroxide, to both sides. Okay? So I would say 14 OH. 14 OH minus plus 14 H plus. Everything else stays the same. And now I have to add that 14 OH minus to the other side. Now this comes together to make 14 water, because H plus OH minus gives me water. And I've got 7 waters over here already, so I can reduce that. Okay, so there's my final balanced reduction half reaction. Now I've got 6 electrons here, 2 electrons here. So when I combine these, I'm going to multiply this one by 3, right? So that I get my electrons to cancel. So 3, this is the combined step. 3Hg, 3Hg plus 6E minus. I'm just going to rewrite this for simplicity. 7H2O. Now we're going to do some cleaning up, and there is some cleaning up that we can do. Actually, no, there's not. It's just the electrons. Take that back. So, gives me my final equation. 3Hg plus 7H2O. And I know that this is being performed in base because there's no H plus, right? You will not have any H plus anytime you deal with a base solution. So there's my final balanced equation. The only difference between acid and a base is that you treat it like it's acid first, and then you do a modification to make it into a base. All right. Let's look at number 6. Okay, let someone at the door. Let's go through this one. now we've got hydrazine that we're dealing with, and chlorate. So N2H4 and ClO3 minus, producing nitrogen monoxide and Cl minus. So let's assign our oxidation numbers. -2 + 1 + 5 -2 + 2 -2 -1. Okay, so let's do the oxidation first. We've got -2 going to +2, right? So N2H4 going into NO plus 4E minus, right? Because to go from -2 to +2, that's a loss of 4. But there are 2 nitrogens to contend with, so I need a coefficient of 2 here, which means I need to change this to 8. And now I need to deal with the fact that I've got oxygens involved. Right, I've got oxygen here, there's coefficient of 2, so I need 2 H2O. And now for my hydrogens, 2 times 2 is 4, plus these 4 gives me 8. Right, there's hydrogen here, and there's hydrogen here, so that's why it's 8. Now that's what it would look like if it were acid solution. Let's go ahead and turn it into base. So to turn it into base, I'm going to add the equivalent of the H plus to both sides. So I'm going to add 8 OH minuses to both sides. So 8 OH minus 2 H2O and 2 H4, 2 NO plus 8 minus 8 H plus 8 OH minus. Now these two together form 8 H2O, which I can clean up because I've got 2 H2O over here. So subtract that out and that gives me 6. So now my oxidation half reaction's balanced. Let's do the reduction. Let's look at what's happening there. So I've got +5 to -1, right? So ClO3 minus is gaining 6 electrons. This is going from +5 to -1. So I'm hitting Cl minus. Coefficient's 1 to 1, so I don't need to worry about changing the number of electrons, but I do need to balance it for the oxygens, right? So I say plus 3 H2O. But now I need to balance the hydrogens. 3 times 2 is 6. Right? Now that's what it would look like if this were occurring in acid, but we need to convert it into base. So let's go ahead and add the equivalent of this 6H plus to both sides. So 6 OH minus plus 6 H plus so a little bit of writing. There's 6 there. Okay, now this and this come together to form water. Right, and then I've got 3 waters over here already, so we can go ahead and erase that and make it a 3. And now I've got a balanced half reaction. So now I'm going to look at my coefficients and figure out what can I do to make them cancel. I've got 8 here and 6 here. I could multiply this whole thing by 6 and this whole thing by 8. That'd make my coefficients really giant, right? So what's the least common multiple of 8 and 6? Right? It would be 24. So if I multiply this one by 3, right? Because 8 times 3 would give me 24. And I multiply this one by 4, 6 times 4 will give me 24. I'm running out of space. Let's combine those and see what we get. Rewrite what it looks like after we multiply through. So this is the combine step. So we get 24 OH minus plus 3 into H4, 6 O, 24 electrons. And then we've got 12 H2O, 4 chlorates, 24 electrons, 4 chloride, 24 hydrox. All right, ran out of space. So now we've got some major time cleaning up to do. Right, our 12 H2Os come out here. And then we've got hydroxides to cancel out completely, 24 OH minus, 24 OH minus, and then we've got our 24 electrons that go away. So we're left with 3 into H4, 4 ClO3 minus, 6 and O plus 4 CO minus. And there's our final redox reaction. Okay, we have 2 more to go. I'm going to pause this for just a second. All right, sorry about that. Had someone at the door needed to talk to me. So let's do number 7. So again, these are occurring in base solution, which means we're going to treat them like they're acid, and then we're going to make a modification at the end to turn it back into base. So let's do our number 7 problem. We've got bromate, so BrO3 minus, and hydrazine, which we just dealt with in the previous problem, producing Br2 and N2. All right, oxidation number time, +5, -2, -2, +1, 0, and 0. All right, so for the oxidation, we are going from, let's see, from -2 to 0, right? That's a loss of 2 electrons. So N2H4 going to N2 plus 4E minus. Why is it 4 and not 2? Well, 1 nitrogen would lose 2, but there are 2 nitrogens here, so that's why it's 4, okay? Again, these oxidation numbers are written not based on quantity of atoms, it's just based on the oxidation state. It's not taking into consideration anything else, right? So there are 1 nitrogen loses 2, and 2 nitrogens are going to lose 4. All right, so now we need to balance the hydrogen. So that would mean 4H plus, right? Because there's 4 here. Now, if this were occurring in acidic solution, we'd be done. However, this is occurring in basic solution, so we need to turn it into basic. So we take the equivalent of this hydroxide and add it to both sides. So that means we've got 4OH minus being added to each side. And then we combine this as 4H2O. Okay, so there's the oxidation side. Now let's do the reduction side. Bromine's going from +5 to 0, right? So that's a gain of 5 electrons. So BrO3 minus plus, it's going from +5 to 0, 5 electrons, Br2. Again, though, we have to watch out. We have, oh, hello? Yes. Okay, hang on just 1 second, okay? 1 second. Sorry, guys, I gotta pause the recording, got a phone call here. All right, let's finish this. So, where we were, like I said, if one bromine gains 5 electrons, well, there are 2 bromines, right? So 2 bromines are going to gain 10 electrons. Okay, so now we just need to turn the rest of this balancing act to match the oxygens, right? So we've got 2 times 3 is 6, right? So we need 6 H2O, and then 6 times 2 is 12, so we need 12 H plus. And if this were occurring in acid, we would just stop right here, but this is occurring in base, so we need to add the equivalent amount of hydroxide to offset the H plus. So 12 OH minus plus 12 H plus, which will come together to form 12 H2O. And then writing everything else. Okay, we've got 12 over there and 6 over here, so we can go ahead and reduce that. Okay, so now we've got 4 electrons and 10 electrons. So what are we going to do? We could turn them both into 40, but that seems a little unnecessary when we can turn them both into 20, right? Because if I multiply this one by 5, that makes this 20. And if I multiply this one by 2, that makes this 20, right? You could have turned them both into 40, but your coefficients would be a lot larger than they need to be, right? The least common multiple here between 4 and 10 would be 20. So multiply this one by 5, multiply this one by 2, and I'm out of space, so I'm going to rewrite the combination step. So for the combine, let's see, we've got okay, and then 12. All right, now let's do some condensing. 20 from 24 gives me 4, and 12 from 20 gives me 8. And my electrons cancel out. So I'm left with the final answer. Here's my final answer. Again, order doesn't matter so long as you've got the correct coefficients and they're in the correct places. All right, last one. We've got aluminum metal and nitrite. And I'm making an anion and ammonia. So, give myself as much room as possible. Okay, that's as high up as I'm going to get. All right. So, Al NO2 minus, AlO2 minus, and H3. All right, oxidation numbers 0, plus 3, minus 2, plus 3. minus 2, minus 3, plus 1. All right, let's do the oxidation. So aluminum is going from 0 to plus 3, so that's a loss of 3 electrons. Okay, so that would be Al becoming AlO2 minus plus 3 electrons. Now I've got to deal with the oxygen component. I need 2 oxygens here, so 2H2O. And now I need hydrogens, so I need 4H plus. But this is not occurring in acid solution, it's occurring in base. So I need to turn it into base solution by taking the equivalent amount of the H plus and adding that hydroxide to both sides. So that will be 4 OH minus going on each side. And then this and this come together to make 4 waters. But I've already got 2 waters over here, so I can subtract that out. And there's my balanced oxidation half reaction. Now let's do the reduction half reaction. So nitrogen's going from plus 3 to minus 3, right? That's a gain of 6 electrons. So NO2 minus plus 6 electrons, making NH3. All right, let's balance our oxygens. We need 2 oxygens over here. So it would be 2H2O. Now in terms of hydrogens, I've got hydrogen here and I've got hydrogen here, right? So 2 times 2 is 4, plus 3 is 7. Right? Because I've got hydrogen in the NH3 and I've got it in the water. So make sure you consider both sources. Now this is what it looked like if it were acid, but we know that it's base, so we need to add the equivalent amount of the hydronium and the hydroxide. So 7 OH minus plus 7 H plus, that means 7 water, plus NO2 minus plus 6 E minus NH3 plus 2 H2O. Don't forget to add it to both sides. Right? Now I've got 2 waters here, 7 waters here, 5 will be the leftovers. Now I look at them and say, what do I need to multiply by? Well, I'm in luck this time, right? Because this is 6. 6 is a multiple of 3. Woohoo! So I can only just get away with multiplying one of them instead of both of them. So I'm just going to rewrite this underneath because I'm running out of room. All right, so let's multiply this by 2. So that gives me 8 OH minus. Multiplying by 2 plus 2Al, 2 AlO2 minus plus 6 electrons plus 2 times 2 is 4 H2O. All right, so let's add these up. So let's see, hydroxide we've got here and we've got here. So this cancel. We've got 5 H2O here. We've got 4 H2O here. So that cancels. And then our 6 electrons cancel. So that gives us OH minus plus 2Al plus H2O plus NO2 minus 2AlO2 minus plus NH. And there's my final balanced equation. All right. So this video ended up being a lot longer than I planned on because we had some interruptions, but that's okay. So if you have questions about balancing redox in either acid or base, please feel free to contact me by email or coming to office hours. And I hope that this helps you.